Let's now calculate the potential difference for some sources that we've been using Gauss's law for. Let's take our first source to be two thin, infinite parallel plates. So we have plus sigma and minus sigma. And let's take this to be our j hat direction. And we'll even choose a y-axis here. Here's y equals 0, y equals d over 2, and y equals minus d over 2. Now, from Gauss's law, we saw that there's an electric field from these sources that points down. And in between the plates, the electric field from the source was minus sigma over epsilon naught j hat. And we found that from our Gauss's law calculation. And so now we want to calculate the potential difference. And let's take the potential difference from the upper plate. So imagine we have a point B up there and a point A down here. And we're going to look at VB minus VA. And our definition was the integral from A to B of the electric field dot ds. Now, one of the things that we have to look at is to make sure that we have a good coordinate system. And what path should we take? We know this result is independent of the path. And so I'll just consider a straight line path. And ds is going to be dy j hat. Now, once again, we don't put a plus or minus sign in here. You'll see the endpoints of the integral will tell us that. We have the expression for the electric field. And so the potential difference, v at y equals d over 2, that's b, minus v at y equals minus d over 2, that's the lower plate, is equal to the integral of this dot product. J hat dot j hat is 1. And so we have another minus sign, minus sigma epsilon naught dy. And here we're going from y minus d over 2 to y equals d over 2. And this is a straightforward integral. It's just equal to d. The two minus signs come out. And we get sigma d over epsilon naught. And if you'll notice, this quantity is positive. And that tells us that the upper plate, the positive plate, is at a higher potential. This is a higher potential. And the lower plate, this is at a lower, the negative plate is at a lower potential. And even notice that the electric field in this example is pointing from higher potential to lower potential. So here's a classic example of a simple calculation involving potential difference for one of our basic Gauss's law superposition examples.